Now we're going to do tab 20 of subprogram 1. It sets a position X and Y, uses the tick number, which is modded with 96. So R, which is the angle number for rotation, is going to go from 0 to 95. Then it gets multiplied by 10, so it's going to go from 0 to 950, meaning it's going to go all the way around the circle, and then the last 10 will go to 960, which is a full circle. Then it's going to take the random numbers at RANV and put them into value, the first 100 of them. Then it's going to make a moving average out of those 100 random numbers, where a random number is 75% of the previous value plus 25% of the next number. So value is going to have moving average numbers. Those moving average numbers are going to be used here to create the size of vectors. It's going to go for I of 0 to 79, therefore making 80 vectors using those random numbers. So it's going to vary the size of the vectors as it goes around the circle. Here's where it makes the vectors based on the position X, Y, and going the different values of R away from the center. Here's where it adds 12 to R, so it goes around 80 times. 80 times 12 is 960. After that, it's going to add another point to make it complete the circle. So it goes back to the very original point. So the point at plus 80 is set to the 0 point for X and Y. And it says there's 81 points. Here it makes the points into values to be used by a polygon. And here's the color for the polygon. Now we'll execute the application. Here is the polygon that it made. Notice it has random configuration. Now we'll go back to the program. The next part of this routine is going to do a morph of one pattern, 86, to another pattern, 85. It's going to have a distance between the two patterns of 200 pixels. It's going to have a percentage of one pattern over the other, figured out here by tick T50, which means this value of T is going to go from 0 to 49. But it gets multiplied by 2, so it goes from 0 to 98. Here's the first morphing. Here's where it gets how many values are in the pattern, and it puts it in N, and then subtracts 123, well, this value here from N. That'll give it the actual number of values in the pattern. Patterns always start with this number plus the number of positions. Here it goes around and moves that pattern 200 pixels, because every value in a pattern has these three numbers for X and these three numbers for Y. So it moves it over to the right 200 pixels. Here's where it brings in the other pattern. Here it makes the polygon fill. Let's execute it and see what's happening. It's taking the pattern U, moving it 200 to the right and creating a V. Go back to the program. The last part of the program is going to show a picture. The picture will be tilted 120 degrees to the right, which is halfway. The size is going to be 150. It's going to be 150 tall, but 200 wide. It's going to be positioned at 870 for X, 150 for Y, and the picture is going to be picture 100. So now we'll execute it. And here we see the picture. Notice it's tilted 120, which in degrees is 45 degrees. And that's it for now. Now we're going to perform tab 21 of subprogram 1. Down here we see it's going to get a pattern. Turn the pattern into dots to draw a line. Make the color black and then draw the line. Up here are the parameters for the X and Y, how tall, how wide, the size, if it's rotated at all, and this is called the quill. How wide is the line going to be? Here it says 3 pixels. Well, let's take a look at this. Here we see that pattern, and it made lines. What's interesting about this pattern is that you see the trace lines going to make each one of the inside circles. Every time there's an inside circle, you see a trace line. Here, and then here. Now you see these traces because it was said to draw lines. If this were told to draw a polygon, you wouldn't see the trace lines. It knows they're not to be shown. So you would just see this object with these holes in it and this little rectangle in it without these trace lines. Now let's go back to the program. The next thing it's going to do is draw an oval. Here it says how tall, how wide, and X and Y values, and the color, well, this is green, so it's going to be a middle color of green, and here it says do the oval. So here we go and look at it. Here's the green oval. Now we go back to the program. Now it defines more control registers for how tall, how wide, the X and Y values. Now the color is a dark blue, 4. Now it's going to draw a rectangle. Well, let's go see the dark blue rectangle. There is the dark blue rectangle. Now we'll go back to the program again. Now it sets the value of R to 48. Now this is the rotational value and multiplies it by 20. So R is going to go from 0 to 47 and be multiplied by 20. So it's going to go around a circle more than once. Also, the size is going to go from 0 to 47, and it's going to be multiplied by 3. So as the tick increases, it's not only going to be whirling around, but it's going to be getting bigger. And they're in sync with the values are in sync because they're both tick 48, tick 48. So they're going to go together. Then it says it's 150 tall and same distance wide, and its X value, its Y value. Here's the pattern number 287. Here it makes the pattern into dots for a polygon. It says the color is black. Draw the polygon. Here's the polygon. It's both whirling around and changing size at exactly the same time, because the tick was modded with 48 both times. There goes the witch. Now we're going to go to tab 22 of subprogram 1, and we're going to show a picture on the screen. The picture's number is 148. Here is the X and Y position. Here's the size of the picture. Notice it's going to be 400 by 400. Up here it says whether it's rotated, and it says no, it's 0. So you're going to see an image on the left side of the screen. Then it says we're going to get that image off the screen and build image 0. So it resets X and Y, because this X and Y is the upper left hand corner of the picture, whereas where it shows it, this is the central point of the picture. So the X and Y's are actually different because of the way it's positioned. But it's going to get that picture. Then it's going to use the tick function to vary the amount of transparency of this picture. T is going to go from 0 to 61 and then be divided by 2. When you divide the tick's number by a value, it's usually because you want to slow down the change. You don't want it to change real quickly. So that's what's going on here. Really wanted the tick value to go from 0 to 31, but it goes so fast you can hardly tell what's happening. So that slows it down. Then it adds a 100 to that value, because then this pix function knows that this is to make it transparent. Now it's going to put it back onto the screen, but this time it's going to use U and V instead of X and Y. But actually it wants to put it back at the same X and Y, so it sets U to X and V to Y, so it's the same place, and it puts it back. Now let's see what's happening. Here is the picture that it made, and noticeably it slowly fades away, and then it pops back again. Now we'll go back to the program. Now the next part of the program is going to show exactly the same picture, but it's going to show it to the right. Notice the value of X now is 700, whereas before it was 240. Well, anyway, it's going to be further to the right, and it's going to show the picture. But now it's going to show two ways of making part of that picture transparent. The first way is to set up a rectangle, T tall, W wide, at X and Y, and then say to wash it. So it's going to go wash this area, which the value of Y is 60. So let's quickly go back there. That is this rectangle here. It said to wash that rectangle, which means it washed away the picture there. Now we'll go back to the program. There's another way to pretty much do the same thing, except it's more powerful because it's only going to erase what part of the picture is black. However, we're going to use the same definition of the rectangle, except we're going to drop it down to Y of 150 instead of 60. And we're going to change the color to black, draw that rectangle. But then we're going to say, make anything black transparent. So when we go back to our picture, it drew this as black. But then it did the transparent of anything black within that rectangle, and the whole rectangle was black. So this whole area became transparent. Okay. While programming, get information from the glossary by clicking Info. Thank you for watching.